Hello. So now that we're done with energy, wanted to kind of talk over this PowerPoint as we're going into our next section of heat and temperature. Okay, so temperature. We use this term to kind of help us out with our daily lives, right? It helps us with cooking, it helps us know what to wear because of the weather. So we're already kind of comfortable with this use of temperature. But what exactly is it coming from a physics point of view? I don't know if you guys remember this, but at the beginning of the year, when we were talking about states of matter, we did a lab where we saw an ice cube. It was getting hot and it was changing, right? It was melting into a liquid, melting into a gas. And if you guys can remember, what was continuously increasing during this was my temperature, right? So as it was going from solid to liquid to gas, my temperature was increasing. Also, hopefully, we remember that gas particles were moving faster than solid, right? So hopefully we can already have this background knowledge that things at a higher temperature are going to be moving faster. So what exactly is this? It's a measure of average kinetic energy of the particles in an object. So we just talked about energy, right? We know kinetic energy is about motion. So things are moving. How fast are they moving? That's what temperature is all about. So those gas particles, they had a high kinetic energy, right? They were moving really fast. Therefore, they had a higher temperature. So high temperature things are moving very quickly, where lower temperature things, not so much. And we're going to talk about later how heat is going to transfer from the higher things to the lower temperatures. We're used to measuring temperature in Fahrenheit, right? But as you guys know, the US is very different, and we don't use the metric system, where most of the world measures temperature in Celsius. In science, we might see this term Kelvin come up. We like to use this in science because it starts at a base 0. So there's actually no negative temperatures in our Kelvin cycle. But these are three different ways that we can measure temperature. And if you guys ever go out to chemistry, I'm sure you guys will practice kind of converting between these three different types of measurements. So we're going to talk about how things change temperature because we know this happens. Things become warmer, things become colder. And what's actually happening here is that they're transferring energy. So heat. What is heat? If I am experiencing heat, that means that there's a transfer of energy between objects. The flow of that energy always transfers from the higher temperature to the lower one. So the energy from that higher temperature, right, it has more kinetic energy. So it kind of makes sense that the warmer object is going to be the one that transfers um, that kinetic energy over to the colder object. If my two objects are very different, that transfer of energy is going to happen very quickly. It will continue to transfer until they reach the same temperature, which we call equilibrium. So we see in this picture, I have the warmer objects transferring over to the colder objects. If you place your hand on a hot stove, that's a big difference in temperature. So because of that, that energy transfers very quickly, which is why we feel it so fast. And this picture is a great visual of how it reaches equilibrium. So if that red block A is my warm one, it's transferring energy to the blue one, and it's going to continue to do that until they're the same temperature, equilibrium. So a few examples of this. Let's say we have a glass of water and we put ice cubes in it, right? Most people will think the ice cubes are actually just causing the water to get colder. But what's actually happening here is that the warm energy from the water is leaving and going into those ice cubes. Remember, we're always going from warm to cold. So it's not that the ice cubes are causing the water to get colder, it's that the energy in the water is actually leaving. And that's what's causing your drink to get cold. But where is that energy going? It's going into those ice cubes, which causes those to melt. Also, if I have like a hot beverage, like a cup of coffee or hot chocolate, if I just leave it sitting out, it's no longer warm, right? It's because that energy from that hot beverage left the system to go into the air until it's the same temperature, which we get room temperature. So when we're talking about energy, we use this term thermal energy. We're going to do a little activity soon where we're comparing temperature and thermal energy. So we already talked about temperature, right? Temperature is the average kinetic energy. What exactly is thermal energy? Thermal energy is the total amount of kinetic energy for that object. So if there is a large mass, this large object will have a great deal of thermal energy. Why? Simply because there's more particles. And the more particles you have, the bigger your total is, right? So this question here, which has more thermal energy, an iceberg or a cup of hot coffee? Now, the temperature of these, which one has a higher average? It's probably going to be the coffee. It'll probably have a higher temperature. But compare the amount of particles in this huge iceberg, and if I was to add up all of the kinetic energy in all of those particles in this iceberg, the iceberg would have more thermal energy. Because my coffee, if I add up all of those particles, it's still not going to beat that iceberg, okay? So thermal energy and temperature are different, and mass does play a role in it. That's what I need you to know for these two words. Okay, so we're talking about energy transfer, right? Going from hot things to cold things. There's three methods which I need you guys to be aware of. One is conduction. In order to recognize conduction, two objects need to be directly touching each other. They have to be in physical contact. Two, convection. This is where I have fluids, so gases or liquids, where warmer substances will rise and cooler ones will start to sink. So have you ever heard, like, if you're in a building and the third floor is warmer than the first, right? It's because warm air has a lower density and it's going to rise, while colder air is going to kind of go towards the bottom. Examples, this is an example of conduction, right? This pan is hot, and if I directly touch it, that energy transfers through my physical contact. Boiling water or heaters. It's causing the warm air to go up, cold fluids to go down. And this method of energy transfer is called convection. My third energy transfer is called radiation. This is where we're talking about electromagnetic waves. Now, eventually we'll talk about these electromagnetic waves, but for right now, examples of this are going to be sunlight, visible light, fire, right? They're not really touching, but it's transferring energy through these waves, okay? So this is an example showing all three. I have the conduction touching the handle, I have the convection of the liquids, and I have the radiation coming from the fire in the electromagnetic waves. So let's talk about a couple of these. This iron directly touching the clothes would be an example of conduction, right? Direct contact. This cup of coffee has the warmer particles kind of rising on their own. So that would be an example of convection. If I was to touch that cup of coffee and I would feel that heat, that would be an example of conduction. Here, the fire heating up the pan would be radiation, right? Let's talk about the food on that pan. That food isn't directly touching that fire, right? That food is directly touching that hot pan. So the food getting cooked here would be conduction. Toasting marshmallows. Those marshmallows are not directly touching that fire. You could directly touch that fire, but right now in this picture they're not. So how are they getting the energy? This is through radiation. This is an example of convection. I have the warm air and cold air. This is going to be radiation, convection, radiation, conduction. So just a few examples of my three methods. All right, one more thing. Let's talk about certain objects that are helpful in transferring this energy. So we have conduction, convection, and radiation, right? There are certain objects that we can use to help this energy transfer or to prevent it. So if we're in a classroom and I asked you guys to put your hand on the table and the hand on the leg of the chair, most of you guys would notice that the metal in the chair was colder. Why? That's because your hand was a much different temperature than that leg of the chair, so we felt that difference. That metal is known as a conductor, so it speeds up this energy transfer. How are humans able to control heat transfer? We can use reflective materials. These are able to trap heat inside or sometimes keep it out. So if you ever have seen cars with the reflective covering over the windshield, that's to kind of keep all that heat from getting into the car. We have conductors. These are generally made out of metals. So thermal conductors are used to move the heat through more easily. So if we're using anything metal, that's going to allow that heat transfer to just go, right? It's not preventing it. It's this metal substance is allowing that heat energy to transfer through it and continue on moving. Where, on the opposite of that, I have insulators. Like insulation in a house, insulation keeps your house warm by preventing things from escaping. So thermal insulators will prevent heat transfer. So like insulation in a house, some type of mugs or coolers have insulation to prevent that heat transfer from happening. Also, another example that we're familiar with are clothes, right? Our coats, hats, just typical clothes are used as insulators to prevent our heat from escaping. And that's about it. That's all the information we need to know about heat, temperature, how temperature and energy is transferring from object to object.